All right, I think it's the time. So welcome to today's webinar, Rethinking Legacy Modernization with AI. I'm Grace Lee, Senior Product Marketing Manager at Blitzy, and today's moderator. Just a quick reminder before we start, this session is being recorded and will be shared afterward. Please submit questions through the QA panel at any time. We will address them at the end. You can also share any feedback or idea for future webinar in the chat. Now, let me introduce today's speaker, David Byrne. David Byrne is AI solutions consultant at Blitzy. He helps enterprise clients evaluate and adopt an autonomous software development platform for large-scale software modernization. Previously, he led field deployment and built autonomous drone system at Rainmaker Technology and worked on legacy modernization initiative at Accenture Federal Services. David brings a hands-on and system-level approach to translating complex AI capability into real enterprise results. With that, let me hand the mic over to Dave.
Fantastic. Thank you, Grace, so much for the introduction. Super excited to be here today with everybody. Just as a quick high-level agenda, we'll talk a little bit about kind of why enterprise AI modernization fails today, what I've seen actually work with the folks that we partner with here at Blitzy and my experience in speaking with folks in the space, and then highlight a handful of those particular use cases, speaking to the experience we've actually drawn on over the last year plus of being in the market, particularly with financial services and insurance providers in the space that are dealing with this kind of modernization difficulty in particular. Then we'll leave some time at the end for Q&A, as Grace mentioned, so feel free to drop any questions into the chat, and I'll be happy to answer them as we work towards the end of the session. Jumping in, I want to start with framing the problem space in particular around why enterprise AI modernization fails, and modernization broadly has been such a difficult problem for CTOs, CIOs, and engineering leadership as they think about reimagining their business and their legacy systems. I'm grateful and for the opportunity where I spend almost every day now meeting with CTOs and CIOs and these engineering leaders of global enterprises, mid-market companies that are growing fast and scaling. And when they think about modernization, there's been these three paths, particularly as we think about mainframe modernization. There's been three ways in which traditionally we can action on and execute on these initiatives. The first being this kind of automated translation or transpilation of taking existing COBOL and getting Java out without really losing the weight of the existing COBOL syntax. So producing JOWAL on the other side, for example, with no real test to prove functional equivalence, but just trusting that this translation is going to take me from my legacy COBOL estate to a modern Java state. The second is this emulation and rehosting. So taking my workloads off of an on-prem or data center solution and shifting it onto a cloud-based infrastructure system, really just shifting the problem. And I think for these first two here of both transpilation and emulation, shifting the problem space, changing the problem space, but really not solving the core problem of why modernization must happen, which is high risk and difficulty of maintenance, especially as we think about the aging out and dwindling population of engineers that can maintain these systems, and the inherent risk as security becomes more and more the topic of focus for engineering leaders. Having these legacy systems sit, even in a modified state, still holds much of the burden that we see with the legacy systems. The third, and as Grace mentioned, kind of the world that I come from before joining Blitzy, is to bring in a team from an SI and bring in a handful of folks to augment your staff to come in and understand the system as it sits today, interview, speak to the folks, the SMEs that have built this application over decades, if they're still around, redesign and rethink this application and build it into a new state. The difficulty there, though, right, is we're talking about 12 to 36 months at a very baseline level of actually executing these projects. And at the end of the engagement, when someone like my former team and I would leave, the system knowledge that we've built over the time of that engagement now leaves with those consultants, those contractors that were brought in to solve the problem. And so what you get on the back end here is sure a manual redesign and a successful implementation of a modern state, but no transfer of knowledge to the teams that are going to have to maintain this moving forward. And so what we see here traditionally, kind of prior to the dawn of AI with modernization, is there's this trade-off between speed, fidelity, and budget. this kind of constant wrestling of understanding what are we willing to sacrifice and what do we need in order to call this modernization successful. Obviously, the dawn of AI came with a pretty compelling promise to say there's going to be this intelligent tool that was built entirely to understand complexity, take the burden off of my human engineering team, and deliver on the other side, looking at my legacy application, a modern app that is feature-rich, modular, composable, all of the kinds of things that make a modern application more enticing for an engineering organization to maintain. It's a fantastic promise and incredibly exciting. In practice, what we've seen as these tools have become more adopted, more capable, is that they're not quite solving the problem necessary for enterprises and enterprise scale to be successfully modernized. And we're still burdened by this game of telephone that happens at the enterprise engineering scale of multiple teams using multiple tools and multiple pods, all coordinating together, taking this large scale initiative of we need to get off mainframe, we need to get to cloud, we need to decompose my monolith into a cloud native microservices architecture. These large scale problems are still burdened by, even with these fantastic tools that sit alongside my developers, still burdened by the human level ability to execute on a unit of work. And so what we're getting today is certainly a fractional increase in speed for every individual in the organization, but no shift in the way in which the teams are moving through these modernization problems. And it's really no fault of anybody. It's just that the AI tools at the individual model level were not built to solve the kinds of problems we're talking about here. When we're talking about tens to hundreds of millions of lines of legacy application code, just having an understanding of a few set of files in the effective context window of an individual LLM, talking about 100 to 200,000 tokens, maybe 10 to 50,000 lines of code, talking beyond what your most senior, most capable engineer is capable of understanding. We're talking about systems that are just too large for an individual developer, a small team, even augmented by the best tools today, to be able to understand and then modernize. And so Blitzy was really built on the back of a thesis and an absolute necessity to understand applications at the ecosystem and system level, to be able to understand across teams, across domains on the level of millions to tens of millions, if not hundreds of millions of lines of code before we ever write a single line moving forward in the forward engineering state. The difficult problem as we think about a 40-year-old COBOL application with 25, 50 million lines of code is we can't build a faithful functional parity match of that application in a future state if we don't know what we're measuring against. And so the process for us at Blitzy, and the reason why we've been built in this particular way, is to start in step one with deep understanding, module, file level, down to function and variable level, exactly how these applications were built, in a fully language agnostic dynamic knowledge graph, building the understanding deeply. And then in the forward engineering state, not just writing code or generating code, but actually validating at scale that the output that you are receiving is matching the input requirements of the existing application, driving not just 80%, but 90% and beyond autonomy of completion of large-scale projects like these modernization initiatives that teams are facing. What I'd love to do to kind of show what this looks like in practice is I'll walk through an example of what this looks like in the Blitzy platform, and then we'll jump into some of those particular use cases. So as I jump over, you'll see the first step in the Blitzy process to kind of bring this to life for folks that are thinking about how do I make this actionable and take this modernization and move. The first step in the Blitzy process, as we've talked about, is to understand the system. And so all that all starts with context, connecting to a code base, pulling in from GitHub, GitLab, Azure DevOps, or Bitbucket. Oftentimes, some of these legacy applications don't exist in those states today, and we work with teams to move them into a modern Git tracking system. We'll connect to that code base in particular, oftentimes a multi-repository system as well, if we're talking about enterprise complexity. We'll kick off the ingestion and reverse engineering process with Blitzy to build, as I said, that language agnostic dynamic knowledge graph. The process to do so is typically a few hours to a few days of continuous compute, where we deploy thousands of agents from OpenAI, Google, and Anthropic to build out and understand through that dynamic knowledge graph exactly how these applications have been built and architected over time. What teams receive back after that ingestion and reverse engineering process is a full readout and a technical specification document showing exactly what this application does. You'll see on the left on that table of contents, the handful of sections in particular that we are highlighting exactly what this looks like in practice, highlighting from a product standpoint, what is the full feature catalog and the requirements that this application has and how it was built. Understanding of some of the considerations that went into this implementation, some of the constraints and trade-offs that teams had to make, looking at the technology stack and an understanding of how was this application built? What is the underlying technology that this sits on? Looking at some of the flowcharts and an understanding of systems and how data and my users are interacting with this application, surfacing, not just in text-based documentation, but also in visual diagrams showing how is my information moving, how are components related, how do they speak to each other. Maybe, and this is typically where I start when I engage with a lot of the folks that I speak to on a daily basis, is I start in section 5 to say, I need to have an understanding of the high-level architecture of a system. This allows me as a developer to onboard and understand the application better. It helps the teams that we work with start to build that understanding as well, especially on these legacy systems that maybe are maintained by a small team that built it originally, or the team that built it originally is no longer with the organization. And so surfacing this tribal knowledge becomes step one in the process of modernization. It's the deep understanding that for teams like I used to come from, oftentimes took months, if not millions of dollars of effort to get to just a deep understanding of the system as it sits today. And so for us, this is a prerequisite. And for other modernization initiatives, it absolutely should be as well. Regardless of what we're trying to do, to not have a deep understanding before generating code is a failure of the system of a modernization initiative. And so everything for us starts here with understanding in the technical specification and the underlying knowledge graph that we build out, highlighting those relationships. Once we have the deep understanding, we start to work into the forward engineering state. So once we have an understanding of a legacy system, we can start to define what our future state looks like to say, I have an idea of what my task context is. What is my objective? An idea of some of the technical constraints moving into the modern stack. Where do I want to land? And then more importantly, for folks that are transitioning from using the AI assistants or the agentic coding assistants that are built for maybe the individual developer, the shift here is will there be a higher focus on validation and a definition of done to say, I have a tool that will go and run for days, if not weeks on end. And on the other end of this run of the platform, I'm going to get a validated result. I now have a lot of control as I declare what that end result should look like from a measurable standpoint of verification of end-to-end functionality and performance baselines of test criteria, validation criteria, all of the things that go into a large-scale software development process get front-loaded into the defined scope of work. And then Blitzy reflects back to the teams that are using it a full readout of, you've given me a plan to go from point A to point B. I have an understanding of point A deeply. And so what I read out to you now in step 4 of our process is exactly how we're going to get from point A to point B. It's going to read out a clarification of the intent that you've declared, an analysis of the existing system, how the source sits today, a design of that future state target based on the information we've provided, as well as something like a full readout of those rules that we've specified, either in the prompt or in the rules section in step 3 to say, here's exactly how we are going to know we have completed the project at hand. And we will continue to iterate entirely autonomously, again, days to weeks of compute here, calling agents, dynamically recruiting agents, to ensure that all of these criteria are met with pure fidelity to the spec. This step in section 4 for teams that are executing these modernization projects serves as the handshake or contract, so to say, with the platform. You can think of it as if I'm going to bring in an SI to come execute a project, and I need to give them kind of the statement of work, the requirements for the next 12 or 24 months that they need to execute. It's that level of granularity that we expect in section 4 here. If we can sign off, typically with a team of folks on the engineering side, architects, principal engineers, folks from the QA team, if not also folks from the product side, to say, if we were able to execute on this project with, call it a team of 20 developers traditionally in the next 12 months, would this be an exciting result for you? Is this exactly what you would like on the other side? With that level of confidence and agreement to say that this is absolutely what I'm looking for, we sign off and handshake with the team and go into code generation. This is the largest batch of autonomous work in how modernization works with Blitzy, where we're not just going to generate code you'll see in step 3 there, Well, we're going to start with two dedicated phases of just understanding and architecting the solution, scoping out those changes, decomposing this large-scale problem of, again, talk about months, quarters, years of engineering work to complete, decomposing that into a set of actionable steps before we ever get into code generation, in which case we orchestrate tens to hundreds of thousands of agent-to-agent interactions, leveraging OpenAI, Anthropic, and Google state-of-the-art models under the hood to go and orchestrate and execute these large-scale projects. And then along the way, doing QA checkpoints, but most importantly, in the last step, doing a very large and in-depth QA block in the system validation or testing changes phase. This is where we're actually going to run against all of those functional criteria and non-functional criteria that we've outlined previously to say, I want to ensure that I am adhering to the move from my legacy COBOL stack to my modern Java stack. And throughout that process, I want to measurably verify that I've had no performance regressions, that my end-to-end functionality across core user workflows have been maintained. I want to ensure that across unit integration testing as well, I'm seeing full functional parity and full passing against the existing test suite, or maybe a test suite that we've built out into the modern state. All of that validation and verification, again, the same kinds of projects that you would pass off to your engineering team today in their traditional workflow, gets executed autonomously so that on the back end of every Blitzy run, of all of the modernization projects we run, we're not just delivering to teams a massive pull request of a fully modernized application, but also confidence in documentation to show exactly how we checked our work, how we verified it, and exactly how your team can go and verify the same exact results that we've retrieved. And so if you look in section 1, you'll get a high-level readout in the project guide of exactly what has been completed on the large-scale scope of work. So we're talking about here for this COBOL to Java migration on the order of a couple 100,000 lines of code. This was a project that would have taken a team about 570 hours, traditionally with their AI-assisted team. Right? So we're not talking true traditional engineering hours, call it 5 or 10 years ago, but your teams today using your favorite agentic tool or AI-assisted coding tool of choice in their back pocket, sitting in the sidecar next to them as they're developing. So 570 hours. So talking on the order of multiple months of work, almost 15 weeks of work to complete from an engineering hour standpoint. Blitzy was able to complete 557 of those 575 hours. And in section 2, this is really where I like to start focusing. We'll get a readout and an itemized list of exactly what has been complete and what the estimates for each of those projects to be completed would be. And then in section 3, a full readout of exactly how we verified and validated this across automated testing. So for unit, integration, end-to-end, and performance baselines, and the validation and verification at runtime that the application we've built is actually executing on that contract that we signed in section 4. I think also helpful and important to note is in section 9 in the development guide, you'll get exactly the steps required for your developers like myself, to come in and pull this pull request locally onto my own device, onto my own machine, and follow the exact same steps that Blitzy went through and executed to actually get the same results that we're reading out. The ability to say, here's exactly how I'm going to go set up my environment, start up the infrastructure, build, run the application, and verify exactly what I've seen on an output standpoint from the platform. And so it's not just delivering a modernized application, but every step along the way, it's the knowledge transfer as well. It starts in step 2 with a full readout of here's our understanding of the existing state. As a standalone artifact, you can go ahead and download this tech spec if you want to pull it out of the platform and keep it locally as documentation for teams to refer back to. You can check the status of the pull request or of the tech spec to say, is this up to date? Does this have all of the most up-to-date commits? If it doesn't, in the tech spec step, we'll go ahead and update the underlying dynamic knowledge graph and understanding of the application. And so what you get here is not just a one-off project in modernization, but a repeatable process and platform to execute multiple modernization projects across not just COBOL to Java migrations or assembly migrations or the traditional mainframe modernization, but also beyond to modern .NET Framework to .NET Core modernizations, Java upgrades, Spring Boot upgrades, the ability to use Blitzy as the development platform to execute on all of the large-scale projects you're thinking about. And so I want to highlight, kind of with this context, an example as great as walking through a demo project that was successful is. It's also helpful to share a handful of real-life use cases with some of our largest clients that we've worked with to date. And so I want to jump back over and share with everyone here a couple of those case studies in particular. And so the first one I want to share is just on reverse engineering and understanding. Again, as we think about modernization, to understand an application is an absolute prerequisite for us and should be an absolute prerequisite for any team doing a modernization project. We have to understand exactly how these applications work if we ever want to verify that the modern state is actually capturing with full functional parity that behavior that we need. So for this team, Fortune 100 global insurance provider, highly regulated industry, lots of legacy architecture, lots of legacy systems, very common for the folks that we work with. They came to us with over 30 million lines of mainframe code written in COBOL. This code base was difficult to understand. The team had no idea exactly how this application was built or works. They'd been working with a service organization, a system integrator, to help them understand it, start to build this understanding and build a path forward for the modernization journey, build the software factory. And after 9 months of working with the service organization, this SI, they started to provide to them code-based details and understanding of their application that Blitzy was able to produce to them in over a weekend. So for us, in that reverse engineering exercise that we run for it was around 33 million lines of code here. Blitzy came back in 3.5 days with that technical specification document I walked through. It's a couple hundred pages of deep understanding and highlighting how the system works in a level, as they said, more quickly, more efficiently, and with greater depth than the 9-month engagement with the SI. I love the quote that they gave us, that it felt like flipping on the light in a room, whereas previously we've been using a flashlight to look around. So giving the kind of clarity around, we have decades of development work that is buried in this code base, now having visibility and discovery of the underlying structure, being able to not just know about, but quantify the technical debt that underlies this application, a full mapping of all dependencies, including with the data architecture. So actually seeing how this works in a full stack and not just in the application layer as well, gives this kind of team and gave this team the confidence to understand exactly what the journey looks like moving forward for modernization in a matter of days and not in a matter of months. I think as important as reverse engineering is, and again, I'll say it's a prerequisite for us, it should be a prerequisite for every team going through a modernization, mainframe or not. It's also important to highlight what it looks like on the other end with forward engineering. And so for this case, looking at a COBOL to Java refactor for a telecom provider, this was benchmarked at a 12-month project for a team to go ahead and execute to take this legacy COBOL application, migrate it to Vue, Spring Boot, and Postgres. Blitzy was able to, over the course of 3 weeks of continuous compute, complete over 90% of the entire quantum of work entirely autonomously, producing over 400,000 lines of code in 10x faster time to market. This is important to highlight as well. I think to say 400,000 lines of code can be exciting and also scary for teams that think about, what does this look like on the review side? How do I actually get this into production? This is where it's important to note that for every modernization initiative too, the second piece that has to be true is validation and verification. It's one thing to understand the legacy system. It's another thing to build a new system and with confidence and measurable verification say that the future state is working exactly as the legacy state is. And so we aren't just writing 400,000 lines of code and handing it off to teams, but exactly as you saw in that project guide, detailing exactly how to get this to production with clear evidence of all of the validation that went into this production. We will spend as much time as needed in compute on the back end of these runs to ensure that the pull request that is being delivered is as high quality, closer from 80 again to 90% plus autonomous completion of the total quantum of work, pushing towards our long-term goal, and hopefully shorter term than I even imagine, of 100% autonomous software development. But today, achieving 90% autonomy for projects like this, giving that level of verification and validation to teams is absolutely imperative to ensure that what you get on the back end of a Blitzy run is actionable and not just a pull request that sits and is stale in the back burner, sitting as an open PR. I also want to share, I think this is fantastic as well, for an organization we're working with, not just on a single individual project, but across a handful of use cases, right? So not just, you'll see in the middle of that COBOL to Java refactor, again, a fantastic 8x engineering velocity increase against their existing baseline, but also across backend refactors, front-end refactors, going from Angular 10 to Angular 18, building and paving the way for what modernization should be unlocking for teams, which is not just to get off of mainframe and get into a modern stack, but it should be unlocking for teams the ability to then tackle new feature development. So looking at once we're in that modern stack, actually executing 80% autonomously the new feature development on a greenfield claims evaluation workflow, opening the door to do security vulnerability remediation into the future state. I'm talking about real labor cost savings here, real engineering time savings. And what this means for teams is the burden of modernization that has previously held, engineering teams by the neck is no longer keeping them in the dark, but instead it is now an actionable item, something that can be done in weeks, if not months, instead of years, multiple years. And it's freeing up the capacity for development teams to no longer be the bottleneck in their product development organizations. It's allowing them to go back to the product team or go back to the business and say, the multi-year modernization initiative that we've been looking to execute is completed. And we're starting to tackle the product backlog that's been building over the course of a few years, but we're actually making progress on it. Let's start to think about what's next. The last one I'll share, and it's a little bit of a different case, but I think helpful as well as we think about how modernization looks and how it fits. It goes beyond mainframe, and I've touched on this a little bit. But as we think about modernizing, for example, this legacy ERP from a massive monolith into cloud native microservices, it's a fantastic case as well where the results speak for themselves and the quality of improvement of life for the engineers, the deployability of this application becomes immediately apparent. This is a project that would have taken 4 months for 5 FTEs to spend all of their time just getting into this microservices architecture. Blitzy was able to, over the course of 3 weeks, execute this project, complete 81% of it in the initial pull requests, pass over 1,000 automated tests, generate 250,000 lines of validated and verified application code, and enable true 5x development velocity and delivery. And so as we think about modernization as well, I think it's important to highlight that it is not just bound to mainframe, but also beyond mainframe as well, of how do we reimagine the entire application suite that my team has underneath them today? How do I ensure that I'm setting myself up for an agentic future, setting myself up for the next wave of the way in which my users want to interact with the fantastic applications that my team has built over decades, being able to turn them into something that is future ready and not just future proof, is absolutely where teams must be looking beyond just mainframe and beyond just modernization. So I'll pause there. And I'll hand back to Grace. I believe we had some questions come in throughout the conversation. Would love to hear from folks. Any questions that we can answer at this point about the modernization, any of those particular use cases that I can share and go into detail about how we were able to execute those results. Would love to go ahead and take a few of those questions now.
Awesome. Thank you, David. It was a very informative presentation. So let's move to the Q&A. If you haven't had a chance to ask, please use the Q&A panel and we will cover them. And if you want to continue the conversation, scan the QR code on the screen or the link on the that link that I share on the chat to schedule a call free consultation with us. So yeah, we have a couple of great questions and feel free to continue to ask. So first question is, what is used for knowledge graph storage? Is there any rock to store the context also?
Yeah, it's a fantastic question. So to build the knowledge graph, we are going to store this dynamic knowledge graph is built off of the source code itself or any associated documentation that's provided to the platform in the repository structure that we are ingesting. So oftentimes we're working with teams. It's not just source code, but it might be visibility into from the data layer, some of the schemas, maybe a dump of stored procedures, for example, if those exist outside of the application layer themselves, as well as any pair documentation that is going to be helpful. Think about business domain context where, again, we're using models from OpenAI, Anthropic, and Google under the hood here. There's a whole lot of information that sits in every enterprise that is not going to be accessible to a model that's trained on the entirety of the internet. That kind of domain complexity that is informative for our platform to be able to build an understanding of your application absolutely gets front-loaded into context, oftentimes as a submodule or as a subfolder in the parent repository that we're working on. And that knowledge graph then becomes dynamic with not just the source code and how it evolves, but also becomes understanding of the broader system context, the business context at its root.
Awesome. Another question is many of our enterprise application can be migrated to new tech stack. We would like to perform this migration in an iterative manner. Would it be possible to migrate my mission critical application in an iterative manner, running both new application and old application in parallel, thereby make sure the new application working as per expectations?
Yeah, it's a fantastic question, and I think a great place to highlight how we think about actually interacting with teams in a lot of cases. It's a huge ask to do a massive cutover and do an entire modernization in a single run. And so when we work with our clients, we follow a pretty structured crawl, walk, run approach to start with smaller projects to get you hands-on with the tool and build confidence in outputs. What we often call priming the code base. So building out high quality documentation and augmenting that automated test coverage and validation framework. And then oftentimes, as we start these modernization initiatives, it's not a big bang all at once, but oftentimes module by module to go and extract a single piece and then verify and validate that that single module that we've moved into a modern state is functioning as intended. And then maybe in the second run, we extend to 2 or 3 modules that will move together as we build confidence. We obviously want teams. The differentiation of working with Blitzy is the ability to work at scale. And so you'll really start to feel the acceleration of projects as we start to scale up the size of the projects that we're tackling. But we're absolutely committed to building confidence with every team that we work with. And so it's exactly how we've engaged with almost every single enterprise customer is we start small, build confidence, build a repeatable structure, and then execute and scale up the size of the projects that we execute from there.
Awesome. Next question is, I know so what is the context limit, like 1 million LOC for the Blitz? Also, do you have any COBOL language cover or AS400, IBM, Neural, etc.?
Got it. 2 great questions in there. So the context window for Blitzy is hypothetically unlimited. So we have the ability to work with infinite code context. It's not an infinite context window. And I'd be crazy to claim that we have some breakthrough in AI technology from a fundamental standpoint. We're still bound in the same sense by the context window of the individual agent, the transformer architecture, the attention mechanism underlying it. But we are going to orchestrate and use the knowledge graph as an intermediate step of understanding to subvert the shortcomings and the barriers of the knowledge, the context window of an individual agent itself. And so when we think about the individual agent, their total token context window being sometimes 1 million to 2 million, depending on the model you're working with, and the effective context window being 100,000 to 200,000 tokens. Blitzy, instead of trying to push more context into an individual agent, has a hard stopgap to dynamically recruit more agents as we get close to that effective context limit, again, that 100 to 200,000 token limit, to dynamically recruit and scale horizontally rather than vertically, spinning up more agents. It's, you saw that one run there that was a 3-week run. That run consisted of over 100,000 agent-to-agent interactions, dynamically recruiting each other, passing snippets of context and stitching context together over the course of a run. So that's the mechanism that allows us to scale to on the order of hundreds of millions of lines of code with the same fidelity as 100,000 lines of code that is entirely different from how these other tools work. And I think a fantastic piece there is if you have those smaller applications where you can build with an individual agent or a small orchestration team, it's a fantastic use case for an individual developer to go tackle those projects. When we start to get into the millions, tens of millions, really anything over 500,000 lines of code, you start to see the decrease in performance of these tools and these kind of homegrown orchestration systems. It's exactly why Blitzy was built and the problem that we're built to solve. And so it's really the right tool or the right platform for the right problem that we're trying to solve is really the dance that we have to play as engineers. And I think to the second question, being entirely language agnostic means we can work with kind of whatever flavor of COBOL you're thinking of, working with AS400, working with iSeries, working with RPG, CA2E, assembly, really anything you can think of from a legacy standpoint. The platform is entirely language agnostic. It's one of the core inventions under the hood of the knowledge graph is the ability to not, if you've worked with ASTs before where they're language specific, to be entirely language agnostic allows us to really work on these kind of difficult problems that other AI models start to fail on.
Awesome. Another question is there an ability to interact with the knowledge graph to validate business scenarios and logics? Does it include a full functional spec that can be reviewed by business analysts for certain critical use cases?
Yeah, it's a fantastic question. I typically recommend there's a few ways in which you can interact with the knowledge graph. The first is the tech spec, right? So that's in step 2 in the platform. So that's going to be your human readable synthesis or abstraction of the knowledge graph, distilling all of the business logic that an analyst might just want to focus on section 2 and section 3 in that tech spec document to say, this is where the product and feature requirements live as Blitzy understands. And I can read directly from there to validate some understanding. The more ad hoc one-off use case is to use the chat functionality directly in the code base, the chat with your code base, where we're going to leverage the knowledge graph directly, and I can query it in natural language to say, maybe I have some curiosity around this particular user workflow, and I want Blitzy to surface to me in the form of a mermaid style diagram exactly how data and information moves through this particular workflow. Blitzy goes, searches the knowledge graph, surfaces that understanding, then presents to you in the chat interface its understanding via the knowledge graph. And then really the most dynamic and really how I recommend teams to validate the understanding of the application by Blitzy is to do a targeted documentation run. So what I walked through in the platform there was a refactor use case. One of the other core workflows, it'll look similar in process, is a documentation workflow. We're going to actually pass to Blitzy a understanding or a request to say, I want an understanding of this particular user workflow, and I want documentation showing exactly how it functions. Blitzy will go and run for a few hours typically. These runs are on the shorter end of our runs and produce to you in a markdown format exactly how this application is built, how it works for that particular request. So as you want to get more targeted, it's hard to validate a multi-hundred page technical specification document. I have worked with a handful of CIOs that have done it and have read 600, 700 page tech specs, but I don't expect every team member to do so. It's far more feasible to point Blitzy at those particularly difficult, complex, or thorny areas of the code base and ask for a one pager or a two pager outlining exactly how it works to verify the understanding.
Awesome. Another question is when modernizing, how do you capture the human decisions that aren't visible in the code, especially in regulated organization, where those decisions carry weight? How do you let human give the AI feedback when it gets something wrong?
Yeah, so it's a fantastic point. Blitzy is fundamentally the executor of intent, but it's not going to make decisions on behalf of the engineering teams that have either built the application or are building the modernized state. Every decision that the platform takes is directed by the users, either through the prompt and verified in the agent action plan to say, yes, this is the approach that I would like to take. As we think about historically, there's an interesting bit in the platform where if we're working off of a system that's been built in Git historically, for example, we have the ability to look into Git history through kind of an archaeology run is what we would call it to say, I can look at how this branch has evolved over time, look at the comments, look at the code itself, and start to understand what the evolution from maybe the last decade to where it is in the modern state, have an understanding of how we got to where we are from a stream of commits of a few individuals in the organization that have driven a feature development. But at the end of the day, everything that we do is driven by the humans that interact with the platform. Think typically senior architects, chief architects, principal staff, distinguished engineers that are going to be driving the platform. They're the ones that are going to define that intent, define the future state. And when the code comes back and that pull request is returned, if there's any tweaks that we want to make that have been, maybe small deviations in the scope of the agent action plan from maybe something that was only in our head and we didn't realize it until we saw the code output, you can go through the platform and run a refined PR where we give additional context around some decisions that we want to make, again, within the scope of the work that we're doing to say, let's go back into code generation, make a few small edits, continue to verify and validate that the changes we're making adhere to the prior success criteria, just with this new context that the humans have front-loaded into the platform. And so it's very steerable in that sense. It's always driven by humans and never kind of just an autonomous magic button. We press go and we get a brand new application.
Awesome. Another question is how do we ensure that we have a set of baseline on legacy system and the same set of tests were validated against the new modernized system?
Yeah, it's one of the first steps we take, kind of calling back to that crawl, walk, run structure. Oftentimes in the walk phase, so we've gotten teams hands-on with the tool, we've reverse engineered the application we're working off of, and we've done some documentation runs to get teams hands-on. That next step is typically to build and augment that existing test structure. Oftentimes it's building it using the understanding of the legacy system into the future state and then following test-driven development in that manner. So building out from our understanding of the system and speaking to folks, extracting from the business analysts what those core user workflows are, actually building with Blitzy end-to-end integration unit and performance tests, capturing performance benchmarks and baselines and using those as golden inputs, so to say, on the other side of the modernization project to do that verification that we're not getting a performance regression. So there's upfront work. Blitzy is a fantastic tool and an aid to every team working on modernization through the platform to build that verification and validation harness. And it is typically kind of, I'd call it step two in the process. If step one is understanding, step two is to verify and build the validation of our understanding. And then step three would be to start actually executing that modernization. So it's another one of those core workflows in the platform.
Awesome. Another question is related to use case. So in the case study that we share, is just the build portion, or is it including the discovery, documentation, and review, testing, validation? And what was the level of integration used to achieve the success?
Yeah. So as we think about any of these initiatives, we're always baselining off of the full scope. So talking about all the way from discovery, understanding to design of the solution, implementation, the sign off from a QA side, and then the move to production. So when we talk about those baselines, those 12-month or 36-month baselines that we're measuring off of, those are that is the full inclusion of scope of a software delivery project. It's not just the writing of code and the generation of code. And so we're completing in that full scope 80 to 90% oftentimes. So that is taking the work of first in the reverse engineering, taking, for that first example case study, right, 9 months to get to the level of understanding that Blitzy got in 3.5 days, immediately compresses the timeline. From there, you're now enabling your architects building the future state, your engineers building the future state, giving them a tool and a platform and an understanding that allows them to make really informed decisions about the future state, not just general decisions about what a future state architecture looks like, informed by the existing structure. So compressing that timeline as well. The implementation being entirely autonomous is a huge leverage win for teams that otherwise would have spent spinning up a couple of pods of PMs and engineers over the course of 8 months, so to say, to go run and actually do the initial implementation, along with the QA team in an agile manner, actually checking their work and validating it. Instead, Blitzy compresses that entire timeline down as well to say, we're not just going to do the implementation, but also the validation in QA. And what's typically left at the end is that path to production or any remaining steps that we weren't able to verify. Think about if there's certain tests, like end-to-end tests, that we aren't able to validate because we didn't provision to Blitzy credentials to go ahead and log into the finalized web application. And we can't do click through across different kinds of roles in the application. Think an admin versus a standard user. That we can't verify and validate that. And so we'll call that out as work for a human developer to do, configure, either run with a refined PR or just take it locally and execute on. And so we're measuring and benchmarking on that entire life cycle. In our North Star, and what we're really pushing for is to not just give you a pull request and have you feel like this is the end result, but also give you the guidelines and the playbook for this to get into production with some remaining work, that last mile development work for an engineering team to pick up. And so, yeah, it is based on the full scope of work, not just the code writing piece that is far greater in the software development lifecycle.
Great. Is it not recommended for human review the code generated by AI? Based on my experience unsupervised and without knowing the refactor code become difficult to maintain later. Bug fixes become difficult.
Yeah, it's a great question. I think a very timely question. I've seen kind of discourse, particularly online over the last month or two, right? It's kind of this kind of tongue-in-cheek question of, do we review the code anymore? How important is it to review the code? Our recommendation is always to start with dynamic validation as your root. So if we build really strong automated testing, understanding of what those end-to-end workflows look like, and we execute them and they're true, then they don't need as much human review, so to say. And it's not a fantastic use of developer time to go do line by line review on all of those. The dynamic validation should serve as the confidence for that first line passive review. That being said, there are always areas, particularly in regulated industries and with enterprises, that we're going to touch really sensitive areas of a code base. Think payment processing logic, core logic to mission critical systems. That is where we're going to want to have an understanding of the teams that are going to be responsible for the maintenance. They should have direct input into the agent action plan, into the prompt, so that they're not just getting general code output, but code that looks and feels like the code that they would have written otherwise. It's a fantastic time to use the rules section in the platform, where we can actually define some of the standards, some of the guidelines, the architectural standards that we adhere to, that we ask our engineers and developers to adhere to today. The same way that we can front load those to Blitzy gives us a more maintainable output on the back end. It's part of the validation loop. It's one of the interesting pieces is we'll actually spin up agents who their entire job is just to validate against that rule set to say, I've delivered and I'm done with my large scale piece of this pull request. I'm now only going to go check for adherence to this set of rules to say, yes, I'm adhering to reusability guidelines and code style and naming conventions and my architectural standards. And so it gives you more confidence as well. But I'll always recommend that for some of those more deep, sensitive areas of the code base that we're working on, having a human sign off and have an understanding as part of that path to production is a critical piece of the workflow.
Awesome. I think that's the wrap of the today's sessions. And thank you everyone to joining today's session. And thank you, David, for the presentations. And if we haven't covered some of question around the pricing, and feel free to schedule a quick call with us. We are happy to continue the conversation. And if we haven't covered your question, we will follow up via email. With that, thank you everyone joining today's session.
Fantastic. Thank you all.
Bye.